Can drone attacks in mountainous and urban areas be detected and stopped? A pressing question. Hey, I'm Chris. Thanks for being here. This is the next episode of a really interesting series called Counter Drone Technology, where we talk to the best innovators, the best military service weapons developers about how to counter the drone threat. We partner with C-UAS Hub, which is a British think tank called part of SAE Media. And today we're really excited. We're really honored to have a real cutting edge solution that just won some awards from the Pentagon's Joint Task Force in the counter drone sphere. We want to welcome Mr. Gregory Waters. He is the founder and CEO of a company that just got recognized by the Pentagon's Joint Task Force called Matrix Space. Sir, thanks for being here and congratulations on your success.
Hey, thanks, Chris. I appreciate that.
Absolutely. I understand it's a portable 360 radar. It's a cutting-edge radar application that detects drones at all different angles, is networked, has an AI component. You won an award from the Pentagon. Please tell us about this.
I will. Thank you. And we've been fortunate enough to win a couple of awards from the Department of Defense and the Pentagon recently. The one that you may be mentioning is we literally just less than 2 weeks ago were announced by DIU, the Defense Innovation Unit of the Pentagon, as the winner of what they described as the low-cost C-UAS sensing challenge. And this was many field trials out in the real world. With a lot of good companies in that. So we were very pleased and proud to support that mission and walk away with the title. That was the heavyweight title of that one. And just prior to that, Chris, there was a major operation called Operation Flytrap in Germany. This was once again U.S. Army sponsored, but broadly NATO. This is European Drone Shield. And there were 4 winners of that competition that were announced. And this was a live fire event. And we were one of those 4 and the only active center winner in C-UAS. So I'd say it's really been our pleasure to support the U.S. military operations for this portable, low cost, and highly effective C-UAS mission. And yeah, it's great to be recognized, but many more miles to go.
Absolutely, sir. Well, you inspired a handful of questions. One was the dismounted element of this, because there's so much discussion about form factor and how this can be operational in a dispersed kind of dismounted environment. Why don't we start there and talk a little bit about the technology? Then we can talk about some of the networking and some of the AI components in terms of how this operates and what makes it different in the threat environment.
Well, you ask a super smart question with respect to that. So when we stood this company up in 2020, we started this company really revolutionizing the AI component of it. Object recognition, threat recognition using optical cameras is largely a solved problem, but not so with radar. So it's a very difficult radar problem. It's a difficult AI problem. And you need to do both. So when we looked at the landscape, and this was with direct feedback from not only military, but also Homeland Security, from major corporations for critical asset protection, trying to bolt on new solutions to classic military radars simply does not work, either for dismount or for recognizing drones. Because I think, as you know, the United States leads in radar technology, but traditional military radars cannot see these small drones, particularly when they're flying low and slow. So it requires a brand new rethinking of the technology at all levels, the radar, the dismount, which is really a power problem, and the AI itself. And that's what we stood up the company to do. So just to continue on that, a couple of the big technical hurdles you need to get over to have dismountable or portable C-UAS radar is you need to get a lot of range in a very small form factor. And I'll show you one of our most portable devices, but we are delivering now and have been for some time what we believe to be the smallest, lightest, and most portable C-UAS solution in the world, which we call an expeditionary kit. And that kit is a single radar, tripod, battery, AI compute, everything for less than 15 pounds. And that can detect a drone the size of your fist at about 750 meters, as one example.
Wow, you sound like you've hung around the Pentagon for a long time. I appreciate your expertise, and I'm sure our viewers will as well. I had a question about line of sight. I was reading about your technology, and what was interesting is the idea that it's networked and it can help identify targets or groups of targets throughout an urban area or a mountainous area. That's one of the big challenges with radar detection is finding that RF signature, finding that throughout difficult or otherwise cluttered areas.
It's another great question. So and it gets back to the rethinking of how radar works and can be made to work in the first place. So radar is line of sight. So listen, our radars don't see around corners individually. That's physics. That would be magic, not engineering. But if you look at the technical founders of the team, even including myself, we grew up in the cellular industry, 3G, 4G, 5G, cellular, that. Now, when you walk around the corner from a cellular antenna, you don't worry about losing that connection anymore, right? It simply hands off to another cell tower, and it happens fast enough. You don't need to worry about it. And this is a similar type of approach of what we've taken with these network radars. Is to do that over a wide area, you do need some type of a network connection. It could be a Starlink connection or a satellite. It could be anything. But we uniquely have the ability to have this resilient distributed radar networks that will self-form and self-heal, meaning a human being doesn't need to deal with this. If we're in a theater of war, for instance, and for whatever reason, one or more of those individual radar units are taken out of action, they are shot, or they just, for whatever reason, the radar network will reform, right? And you'll be able to do that. So get enough units in the field. And if you make them small enough and portable enough and cheap enough, that's not a hard thing to do. This now gives our warfighters a very strong competitive advantage over our adversaries of getting really fast deployment, which can move. These are movable perimeters on that into the field that are, one, very hard to detect in the first place because they are beam steered and difficult to detect. But second, you get enough of them in the field, it's very, very difficult, right, to take them all out.
Excellent. Well, not to go too far back in history, but this sounds like what you're doing is the next generation of what was attempted and experimented with the Army with things like jitters and WinT, where you have this software programmable network where each node necessarily didn't need a fixed infrastructure, but was itself a router and a relay mechanism across a sphere of nodes to blanket an area past packets of IP information through high bandwidth waveforms. How much of what you're doing kind of builds on that? And is that a correct parallel?
I couldn't tell you. I'm not familiar with those programs, but I will tell. So I can't make the comparison. Those are before my time. But the language you use, like every radar node being a router, passing IP packets, and this is exactly what we do. And this isn't PowerPoint slides. It's not science fiction. It's things that we have deployed in the field. As one civilian example, if you take a look, and this is on our website, the largest non-military radar coverage, we believe, in the world is Palm Springs, California. And that is matrix-based technology that was used in support of local law enforcement to support legally their drone first responder program. And that is over 40 square miles of products doing exactly what you're talking about. Radars broadcasting in overlapping fields of view, turning each other on and off so that they don't interfere with each other or blind themselves. And getting back to your earlier question, Chris, about urban environments, this is about as challenging an urban environment as you get. It's a large area. It's hot. There's buildings and skyscrapers. There's an active airport in the middle of the city, and it all works. So that's one example of just how big an area you can cover with this type of tech, and it does work.
Well, that's excellent. It's potentially paradigm changing in terms of what a lot of the concepts of operation or tactics are aiming to accomplish. In a context of a battlefield sphere, you could have a node or a slightly higher altitude that could then network to a node on the other side of a mountain. So in effect, or a building. So in effect, you're getting an integrated picture across a network of nodes to see things that you're otherwise not going to detect.
You said it better than I could. Bingo. That's it. And in fact, if you want resilience, put a few more nodes out there than you need, right? If any goes down for any particular reason, you've really got that resilience and backup. But what you just described is exactly what the tech is meant to do. And let me tell you where this also goes. This is just for the C-UAS detection capability. But on top of that, for any entity, whether it be the DoD, Ministry of Defense, Homeland Security, anyone, we also not only provide the AI intelligence sensors, but we also supply the artificial intelligent cloud layer that if people want to take any number, 100, 1,000 sensors, and these can be radar, they can be optical, they can be whatever, bring that data back together, use cloud resources or those in a server to apply yet more sophisticated AI. All of that threat identification can be done very, very quickly, less than milliseconds, and push back down to a user, to a smartphone, a tablet, a TAC device, for instance, which we're already integrated to with the military, and it makes our people, our first responders, our soldiers, our warfighters, very, very smart indeed, right? So we've got the sensor part with AI, we've got the cloud part with even more AI.
10-4, definitely want to ask about AI. And another question I had was about fire control and connecting with countermeasures or effectors. To what extent can this networking be aligned with, perhaps this scenario needs high-powered microwave, perhaps this needs laser, but maybe the cloud's obscure. We need a kinetic solution. How does this translate from the detection into possible mitigation or countermeasures?
It's a great question. Now, we don't do mitigation, right? That's not part of our product or our kit, but we can integrate with anybody literally that does, right? And there's different solutions to this. So, for instance, the electromagnetic effectors on that, which also have the benefit of being able to take down entire swarms of drones, in a very short period of time. We give them, we slew them. We give them, this is where the drones are coming from. Our radars can also talk to other types of sensing, like long-range optical, to get even a more precise bearing if you really want to provide targeting information. But also, you'll see that one of our investors and partners is L3Harris. This was announced as part of our Series B raise, who also is quite good at these types of effectors on this. So while that's not part of our business, and I think that's a very rapidly evolving field, I would say that pretty much everybody that is in the effector business is either working or wanting to work with metric space right now.
10-4. And I liked how you talked about passive turning on and off, because the more a signature or signal emerges, the more detectable it can be. So if there's a network, it can feed into, if it's secure or hardened, it can feed into a fire control system that then decides upon or disperses a countermeasure, which brings me to my question. And AI, I love how you mentioned AI at the point of collection. How is AI working with this to sort of make those discernments regarding what a target is or what a target isn't?
AI is essential. And you see AI is a big buzzword right now for anybody. You see a lot of companies running around and saying, we got to get smart, who has not traditionally been part of the AI game, and saying, we got to get smart at this. And we got to bolt this onto our legacy systems. And I will admit, I'm deeply skeptical of those approaches. If you haven't designed for native AI from beginning, it is virtually impossible to do that effectively and well by bolting onto old legacy systems. Now, we began the company as an AI software company before we even started work on radar, so we naturally view it through that lens. But there's two elements, just to simplify a little bit, about AI. And the first one is, if you're in the middle of a field, if you're a war fighter and you've got no network connection, you're moving fast, you may be under threat or something like that, you can't be thinking about AI and trying to provision this. It's got to be lightweight there, and it's got to be fully functional without any connection to anything. And that is the first thing that we do, is no matter what product you pick, and we've got a variety of them, that AI is native, it's local, it declutters the environment, it helps to calibrate that radar to ever-changing environments, which is a big thing, and it provides that object classification and threat identification. Now, if you've got, then to your earlier questions, more than one, well, guess what? The AI works even better. If you've got access to the cloud, well, it just keeps getting better. But even at that really native low level, It's all there. It's all packaged. That 14-pound backpackable thing, full AI, edge capable.
TED 4. Excellent. Well, in terms of AI at the point of collection, I wanted to ask about the form factor of the hardware. Does this mean that almost like a mini hardware node engineered with a sensor and able to make discernments essentially is dispersed across an area to form that network, that self-healing network you talked about? Are they small little mini kind of drone things?
They are. Listen, let me, I don't know how this will come across on a video conference, but I want to show you. This is a backpackable expeditionary kit. If you can see that, I'm not going to bother to set it up, but this can be set up in less than 5 minutes easily, right? There's a tripod, there's a battery. And where I'm going with this, I just want to show you how small this is. This can detect a class 1 drone at well over 700 meters. Dark, right? Works in the rain, works in bad weather. And that is a fully containable kit, if you will, ruggedized, heat sink, runs in the middle of Palm Springs summers, which get up to about 125 degrees, all AI native, right? Designed from the ground up. The Matrix Space Expeditionary Kit.
Excellent. And would you network with an air node or have an air node to sort of get that line of sight over a small mountain?
A really smart question. That's something that we are working on with our partners. You know, we don't build drones, for instance, on that. Many other people do. But if you look at how this can extend, there are so many different positive ways to just keep building in that technology. Super portability. If you have got, for instance, the portable 360 you mentioned, right? Well, that might be hard to carry in your back. But it's easily person carryable, fits in a trunk of a car easily. You can set this up on a perimeter and a border in less than an hour. Then if you want that line of sight, right, we love the tethered drone application, right, where you've got essentially infinite power. You can get those things up to 1,000 feet or whatever. And for sure, you're going to be seeing that type of solution fielded in our near future too.
Excellent. So you absolutely can do that with a tethered drone, maybe a fiber optic cable or just drone that goes up to the altitude to give you that aerial relay.
You absolutely can.
Wow. Wow. Well, what's happening now, one of the most fascinating things about following this networking with the Pentagon and the military services is the military is accomplishing what it has long sought after for decades. This idea of dismounted, non-fixed networking using software programmable radio across otherwise dispersed and non-linear kinds of environments. Back years ago, they put a rifleman radio, which was a jitters radio, software programmable radio, on a drone. They literally taped it or tied it to the wing of a shadow drone to get that aerial node. And so that was an earlier iteration of what's now come to fruition, which is, forgive the little mini speech here, sir, but exactly what you're doing.
Yeah. What we're beginning to do, and the cool thing is, Chris, we're proud of where the company's been. You know, 2026 is our 7th year, right? So it's not, we've been at this for a while on this. But there are so many places this can go in the future. So since you obviously have a background in these software-defined radio type solutions, we have immense programmability under the hood of all of those radars. Next generation stuff gets even cooler on that. So the software innovation is going to go very, very quickly. The second thing that you'll see from us going forward is that while radars is by far the hardest part of the sensing game, by far, particularly if you want to get to that portability, and one of the real huge competitive advantages we have is our low power consumption. So if you're into portable or dismountable solution, your power consumption determines the size of your batteries, and it's just fundamental, right? You can't engineer your way around that. That radar that I just showed you, that single radar panel, that draws 28 watts of power. You know, you add the compute, you're up to maybe 40 watts of power. You can run that for 8 hours on a 4-pound battery with full AI running full tilt as one example. But if you go forward into the future, you will see, particularly for those companies that are investing in and using our cloud platform, you will see networks of radars, just like you would describe, right? Beyond visual line of sight, all these other cool things, dismountable and fixed. You'll see longer range solutions in the future from us coming out with native AI. But you're going to see an awful lot of integration in AI threat detection that leverages other sensor types, such as optical, such as thermal, such as whatever. So it's a platform that once the warfighters really engage and they will figure out new use cases, right? They all want to see, we can really rapidly add to those things going forward once that base platform's in use.
Excellent. Well, Roger that, sir. Gosh, we could talk indefinitely here. My last question is another application which makes sense just thinking about what your technology does. And I believe also reading about it, there was stadium protection, infrastructure, base, forward operating base kinds of applications. This could literally go on top of a building in an urban area that's needing to be defended, or a mountain, or its application could be huge for installations or a stadium like the World Cup that's recently expanded. Put one on the top somewhere, have one at altitude, so you get that connectivity beyond line of sight.
Well, once again, I think your questions are spot on that, and we're not able to comment on all these things directly. But I think for sure you will see matrix space kit, our tech, right smack in the middle, right, of some of the events and some of the protections that you'll be seeing next year. As an example, I believe that the overall organization of security, the coordinated security approach being led by DHS leadership right now to protect the American public and fans of the World Cup may be the most coordinated and sophisticated security event in the history of the United States. And we are always proud to support the mission of DHS whenever we are called upon.
10-4. Well, I have heard that. I've talked to a couple Homeland Security former leaders who say I don't want to say barriers, but the connectivity and the collaboration between otherwise separate elements of government, this whole of government approach is really working, that whether it's local law enforcement, DHS, and then of course the military, that there is a growing amount of synergy there.
It's super encouraging. I have the same view, right? And it's going to be even better, right? 6 months from now than it is. It really feels like it's a different day. It's a different style of leadership that we're seeing coming from DHS right now. And I think it is going to be tremendously positive for the American people going forward.
There you go. You come here for the expertise. Mr. Gregory Waters, COO, CEO, founder of Matrix Space. It's been noticed by the Pentagon for counter UAS kinds of applications and technologies. Thanks for joining our series. Real value added, sir.
My pleasure, Chris. Thank you.